Problem number one says, what is a percent by mass? So we need some kind of mass that we want, So this is part. And since it's percent by mass, the bottom one has to be mass as well. But then bottom one is the whole mass or total mass. Okay. Mass, as we know, it's going to be in grams. So let's see what the part is and what the whole is. The part of the whole thing is what? Magnesium here. So we have 136 grams of magnesium. So 136 grams of magnesium on top, that goes on top. And then we need the whole is the ocean water. But we're given 1 liter of it. Okay. We need to convert liter into grams. So we're given density here. So let's figure out how many gram is 1 liter. Okay, we could have 1.00 liter to start with. This is ocean water. But you see the unit here is milliliters, ml. So we don't need L, so we want to put L on the bottom. We know that there is 1000 ml in 1L, so liters cancel. Let me move that over here to the right, left a little bit. Now we don't want ml, so we put ml on the bottom. So every 1 ml, we know from the density we know there is 1.00 grams of ocean water. So ml cancels out. That's going to be 1000 grams. 1000 grams. That's going to be and then since it's percentage, whatever the decimal, we need to multiply by 100%. That's going to be what? 13.6%. Okay, so this is the answer right there for number one. Let's move on to number two. Number two is pretty simple too. It's asking for the molarity of 90 grams of ammonium nitrate. If you don't know the formula for ammonium nitrate, you can't do this one. So ammonium is NH4, it's +1 charge, and then nitrate is NO3 ion, but it's -1 charge, so they cancel out each other in charge wise. So this is a formula for ammonium nitrate, and we're given liters. What is molarity? Molarity is number of moles of the things dissolved in it, solute, over liter of the whole solution. Okay, so we got liter of the solution here, but we don't have the mole of ammonium nitrate. We're only given grams. So just convert gram into moles. That's all you got to do. And then put it above the 2.25. Here we go. So 90.0 grams of ammonium nitrate. And then we need molar mass. Okay. It's 80.06 molar mass. So grams of ammonium nitrate for 1 mole. NH4NO3. And then since we have moles, the grams cancel out. We need mole. We have the mole of the solute, but we have to put liter of the solution, which is 2.25 liters. So I'm circling the unit, mole over liter. That's the molarity. So all you gotta do is just multiply all the numbers on top, divide the numbers on the bottom. So we got 0.4996. Let me see, it goes on and on, 25. Let's look at the problem. Let's see what numbers we used. That's 3 sig fig. And so is this, 3 sig fig. So let's have our answer in 3 sig fig. Right there is the last sig fig, but the next number is greater than 5. So we round it up. It's 0.500 you gotta put in. And it's in molarity. You could put capital M, or you could put 0.500 mole over liter. That doesn't really matter. Okay, so let's move on to number 3. Number 3 says, calculate the mass of sodium hydroxide required to prepare 2500 ml of that concentrated solution. Okay, so we're given, let's convert this into liters first. 2.5 liters of, the concentration is that, what is that? 0.343. That's equivalent to moles of NaOH over liter of the solution. Oh, when you look at this, this is the amount, this is concentration. What happens when you multiply? Liters will cancel, and it's going to give us the number of moles for NaOH dissolved in there, right? So all we need to do is change mole into mass, which is in grams, using molar mass. Okay, So let's start with 2.5 liters of the solution, but then concentration is 0.343 mole of NaOH over 1 liter of the solution. Okay, so liters cancel. Now for 1 mole of NaOH, you need to find the molar mass and put it up there. Let me find it. So it's 40.00 grams of NaOH. Okay, so that cancels out, moles cancel out. We're left with grams of NaOH. Multiply the numbers on top and divide the numbers on the bottom here. It's 34.3 grams. Let's check our sig fig. This is 2 sig fig to start with. This is 3, so we multiply everything. Let's convert it into 2 sig fig. So it should be 34 grams of NaOH. Let's move on to number 4. Number 4 says caustic soda, which is 19.1 molar. NaOH is diluted for household use. Okay, so whenever you see word diluted, it's probably adding water, and it's a dilution problem. Okay, so that means molarity of 1, M1, V1, volume 1. That when you multiply these two, you're going to get number of moles. That should always equal to the diluted ones. So second concentration, molarity 2 times V2. So remember this. In dilution problem, you're going to see this. Okay. What is the household concentration molarity after it got diluted? If 12 ml of the original concentrated solution, that's 19.1 molar, is diluted by adding just the water of this much. Okay. Unit-wise, if this is one of the V is ml, then and the other one is V2 is also ml, it's okay. They're gonna cancel each other out. You don't have to change it to liters. Okay. So let's label this. This is the original concentrated one. So I'm gonna call that M1, molarity 1. And how much are we putting that? We're putting 12 ml of it. So this should be V1. Okay. Now the new amount of water we're adding, we're adding 286 on top of 12. So you need to, V2 is going to be 286 ml plus 12 ml. So it's going to be what? 298 ml. So that's our V2. Be careful. Okay. Water is being added on top of 12 ml. Okay. And the, what is it? M2, the molarity of the diluted solution is what we're looking for. Okay. So we've got M1, which is 19.1 molar, and V1, which is going to be 12 ml. That's going to equal to molarity of the second one. We don't know. We're trying to figure that out. V2 is 298 ml. See how ml, when you divide it by, they cancel out. Molarity of second one is equal to molar in terms of unit. Okay, that's what we want. So molarity of the second one, which is the diluted one, all you got to do is 19.1 times 12 divided by 298. Let's see what that is. It's going to be 0.769127 molar. Let's keep our sig fig correctly. That's 3 sig fig. This is 2 sig fig. This is 3 sig fig, so we want to have up to 2 sig fig. Look at the next number. It's greater than or equal to 5, so it should be 0.77 molarity. Okay, let's move on to number 5. It says write equilibrium constant, KEQ. Okay, expression for the following equation. So we need, before we do this, you have to balance the equation first. Okay, let's see. We got 2 NAs on the left side, 2 NAs. So we're good. Oxygen-wise, it's all different. You got 4 here on the left side. You have like 5 here. So since this guy has 3 oxygen, I'm going to multiply by 2 to make it 6, to make it even. If I do that, I just double the sodium. So I'm going to put 2 over here. Now, since because of this 2, this carbon got doubled. Now I have 2 carbon on the right side. So I need to put 2 here. Now, how many O's do I have on the left side? 2 times 2, I got 4, and then another 4 here. I have 8 oxygen. On my left side, this is 6, and yeah, 6 plus 2 is 1. So 1 right there. So you need to balance everything. Now, KEQ, equilibrium constant, is always the product concentration on top. Remember that, okay? Product. If you have more than one product, just multiply everything. with the coefficient being power. Okay, let me just do it right now. So Na to CO3, concentration of that squared, that becomes exponent. Concentration of that multiplied by another product, oxygen, to the first power. I don't want to put 1. You get the idea. Divided by the reactants now. Na2O2, concentration of that squared times, remember it's times, it's not plus or minus or anything, and then CO2 to the second power. But here's a big but. If you're writing KEQ, okay, equilibrium constant, all the solid and liquid, like water, they become 1. Okay, so this is solid, so this becomes 1. Okay, or you could just get rid of it because we're dividing and multiplying it. This is 1. And another solid right there, so this becomes 1. Okay, 1 to the second power is 1, 1 to the second power is 1. So basically all you need to write is concentration of oxygen on top over concentration of carbon dioxide square on the bottom. That's it. Let's move on to number 6. Okay, number 6, we're actually given the concentration for each species here. So we need to figure out KEQ is after we balance it. Remember, you got to balance it first. Okay. So we got N2O2O, only one N and one O. So I'm going to put 2 here. It should be good. Now we're going to answer that in a minute. Let's write KEQ. Okay. KEQ is going to be NO, making sure everything's gas or there's no solid or liquid, so we have to include it. Concentration of NO squared because of that coefficient over N2 on the bottom and then O2 on the bottom. Okay, so all you got to do is just plug in these numbers. They're all in molarity, mole over liter. Okay, let's go. So NO, nitrogen monoxide, is 5 molarity, okay, squared over, you know what, I'm not gonna, it's unionless anyways. So 5 squared over, N2 is 2.5, and then O2 is 2.0. It's going to be, what, 25 over 5, which is going to be 5. Sig fig, since this guy has only 1 sig fig, I'm just going to leave my answer as 1 sig fig. If KEQ is 5, it's greater than 1, which means if it's greater than 1, you're going to have more of the product, okay? Because the numerator must be greater than the denominator, which means products are favored. Products are favored. If it's less than 1, the reactants will be favored. Let's move on to number 7 now. Okay, number 7 says, this time we need to figure out the concentration of oxygen, where KEQ is given. Okay, again, before we do anything, what? You need to balance this. All right, let me see. You have 1 N. Their O's are everywhere, so I'm going to do O's in a minute. We got 3 H's here, but we only have 2 H's here. So I'm going to multiply this by 3 and put 2 here to make it 6 H's. Now, by putting 2 here, nitrogen, I have 2, so I'm going to put 2 here. Okay, but no matter what we put here, the oxygen will be odd number because of 3 H2O. It'll be odd number of oxygen, right? So in order to fix that, the simplest way is just multiply by 2. So make this 6. I'm going to make it 6 now. Okay, by putting 6 there, I now have 12 hydrogens. So I'm going to put 4 over here to make it 12 hydrogens. Now, I have to have 4 nitrogens. So I'm going to put 4 here. Okay, now let's count oxygen here. So that's going to be 4 here, 6 here, 10 oxygen. I now have, so I have to put 5 there to make it 10 oxygen. So that should do it. 4, 5, 4, 6. If you balance it and somehow everything's even, you could just reduce it by divided by 2. Okay? Now, remember KEQ is going to be the making sure everything is not, like everything is gas, or AQ, aqueous. If it's solid, you don't have to put it there. If it's liquid, you don't have to put it here. So we got concentration of NO to the 4th power multiplied by concentration of that vapor, water vapor, to the 6th power, everything over. NH3 concentration of that to the fourth power, and then concentration of oxygen gas to the fifth power. Okay, the unknown here is what? We need to figure out oxygen. So this is the unknown. Okay, oh, not to the fifth, just this portion. Okay, now let's plug in numbers. Okay, when you have a ratio like this, you could just switch these two because KEQ is the numerator of the other side of the equation. Okay, so it's like this. If you have 3 is equal to, let's say, I don't know, 6 over 2, then you could switch these two places and make it 2 is equal to 6 over 3. They mean the same. Okay, see how they're equal? So I'm going to do that. Okay, so I'm going to switch. I'm going to put O2 to the fifth, O2 to the fifth on the other side of the equation, becoming numerator, and then just plug in numbers now. NO to the fourth is what? 1.865 to the fourth power. You have to be careful. There'll be a lot of numbers here. Water to the sixth power, 0. It's not water, vapor, but vapor, 0.135 to the sixth power. Everything over. Ammonia, 0.235 to the fourth power. And then KEQ goes bottom right there. So KEQ was 1.72. And then to get rid of that fifth power, what do we need to do? We need to raise everything to the 1/5 power. How about that? Okay, because power to power, when you multiply, this becomes just oxygen. So this becomes the concentration of the oxygen. Okay, now take out your calculator. Be careful when you solve this. Okay, so evaluate this. So when you calculate that out, it's going to be 0.426 because the sig fig here is 3. And the unit must be molarity. Or you could put mole over liter, just like the other ones here. 0.426 mole over liter. Okay, let's move on to number 8. Number 8 says HCl, hydrochloric acid, or HCl gas is added to the mixture, okay, to the previous problem, and it reacts with NH3. If it reacts with it and then it forms H2O, what would happen if you put HCl in it? It will grab onto this ammonia here, okay, so that NH3 concentration will go down, correct? And then it says it forms extra water or vapor gas here. So you would increase the product here, okay? This will cause a stress. So according to the Laqueous principle, if you add more product, it will shift to the left. At the same time, if you take away the reactant, the whole reaction will shift to the left, right? So reaction will shift to the left to relieve this stress because you're ending up what? You end up putting more products. So product goes up as well as the reactant goes down. Okay, so it shifts to the left.